Hi, hello! In this video, we're going to talk about multiplying and dividing decimals. So let's go. In our first example, we have 3.47 multiplied by 2.8. How are we going to approach this? Unlike adding or subtracting decimals, we do not need to align our decimal point. So we can use standard algorithm to multiply. What I'm gonna do now, I'm gonna pretend that the decimal points are not there, and I'm just gonna multiply 2-digit number by 3-digit number. We should know how to do that by now. 8 times 7, 56, let's write 6 and memorize 5. Then 4 times 8 is 32 and 32 plus 5 is 37. We're gonna write down 7 and 3 will be here. Okay, now we have 8 times 3, which is 24, and 24 plus 3 will be 27. Okay, now let's multiply 2. 2 times 7 is 14. We're gonna write down 4 and put 1. 4 times 4 is 16, and 16 plus 1 is 17. 2 times 3 is 6, and 6 plus 1 is 7. And we get 10,516. We're not done yet because the thing is we ignored our decimal points, but we cannot really do that with our answer. How are we gonna put our decimal point? We're gonna count how many digits do we have after our decimal point. We have 4, 7, and 8, so it's 1, 2, 3. And then I'm gonna count back 3 digits and put my decimal point. And my final answer is 10.516. Let's do another example. 5.93 multiplied by 0.6. I'm gonna show you another way that you can do it. I prefer this method. If you don't, stick to the first one. This is how my brain works. I'm gonna show it to you. If you like it, use it. If you don't, don't. What I'm gonna do, I'm gonna convert each decimal into a fraction. Why did I do this? Because I know on my denominator, I'm gonna have 1,000. I do not need to count how many decimal, because I have 1,000 in my denominator, I do not need to count how many digits I have after a decimal point. This way, it makes it more intuitive for me. Okay, if it's not, then count back. Memorize it. I don't like memorization, so let's keep going. We have 593 multiplied by 6. 6 times 3 is 18. 9 times 6 is 54, and add 1, 55. 5 times 6 is 30, and 30 plus 5, 35. So we get our new fraction, 3,558 over 1,000. And now I can convert this fraction into decimal, and we're done. Let's try another example. 2 multiplied by 3.8. I'm gonna use standard algorithm. I'm gonna get 76 as my answer when I multiply. However, I didn't put the decimal point. I see that there is only 1 digit after decimal point, so I'm here also gonna put 1 right there. And my final answer is 7.6. Starting to feel a little bit more comfortable. Okay, let's keep going. In this example, I have 6.4 multiplied by 4.55. Keep using standard algorithm. 5 times 4 is 20, 22. 4 times 4 is 16, and 16 plus 2 is 18. 6 times 5 is 30, and plus 3 is 33. And 4 times 6 is 24, and 24 plus 3 is 27. And we get 29,120. Let's count how many digits we have after decimal point. We have 1 here and 2 here, so 3 in total. Count back 3. 1, 2, 3. Put decimal point, and my final answer is 29.12. You keep adding as many zeros as you... Listen, you can add as many zeros as you want after the last digit after your decimal point. And what I mean is that you can keep adding zeros and nothing changes. Or here you can keep adding zeros in front and nothing changes. What we can do is just remove them And again, nothing changes. Okay, now let's figure out how to divide decimals. I have 87.1 divided by 3. Unlike multiplying, here you actually need to remove that decimal point. To remove the decimal point, you're gonna move it. You're gonna move it to the right. If you move it to the right here, then you also need to move the decimal point here. I'm gonna show you what I mean. This 3 has an empty space. Empty space is going to be filled with a 0. What I'm finally going to have, I'm going to have 871 divided by 30. Use long division. Can we divide 8 by 30? No. Can we divide Can we divide 87 by 30? Yes. Okay, let's do how many times does 30 fit into 87? It's about 2 times. 2 times 30 is 60. Subtract. Okay, 7. Now I have 271 divided by 30. Let's figure how many times will 30 fit into this. Should be around 9 times. 9 times 30, it will be 270. And we get 1 as our remainder. However, we also need to deal with the remainder because we are doing decimals. We do not end there. If we want to keep adding numbers, we need to put decimal points. So 29 will be our whole number, put a decimal. Then I'm gonna add 0 here. Okay, can we divide 10 by 30? No. If we cannot do that, it's gonna be 0. So 10 minus 0. No. And then we can keep adding as many zeros as you want to figure out as many digits after decimal points as we need. Okay, 100 divided by 30, it will be 3. 3 times 30, I get the same thing. I have 100 divided by 30 and I've already had that. I can write 3. And this will be never-ending loop. So I'll keep having 3, 3, 3, 3, all the way to infinity. And your final answer can be 29.3. And you can put this little mark to show that 3 is never ending and it keeps repeating itself. And you do not need to count, okay, how many decimal, and you do not need to, and you do not need to count how many digits you have after decimal point, etc., etc. In this case, you are just going to move it. Another way I would do it, I would convert it into a fraction and then divide by whatever I have. If you like it, use it. That's what I like, that's what I use. If you don't like it, then use what I showed you before. Let's keep going. Here I have 5.056 divided by 8. What is going to happen? I need to move the decimal point 3 digits. If it moves 3 here, then it also gonna move 3 there. These empty spaces will be filled with zeros. And I'm gonna get 5,056 divided by 8,000. Does 8,000 fit into 5,000? Not really, so it's gonna be 0. Now, before we add a 0, we gotta add decimal point. Then I can add another 0 and keep dividing. Okay, now we have 50,560 divided by 8,000. Okay, 8 times 7 is 56, so no. How about 6? 8 times 6 is 48. Okay, 6 should work. So it'll be 40. Okay, and then we can add another 0. When we add another 0 after we already put a decimal point, we do not need to add another decimal point, so we can just keep adding zeros. Okay, 25,600 divided by 8,000, it will be around 3, right? 24,000. And when I subtract, I'm going to get 1,000. 1,500. I can keep adding zeros and dividing. Though I think 2 digits after decimal point is close enough to estimate, find the answer, and we'll just put 0.63 as our answer. Does this make sense? I really hope it does, because a lot of my students, they're like, I don't know how to do long division, and then I see they do it with no issues, and I'll be like, why did you lie to me? You know how to do long divisions. Why are you telling me you do not know how to divide decimals? You just did that. Like, oh yeah, I was bad at it, but now I'm good at it. Let's do other examples with division. I think we should. I have 9.4 divided by 0.5. This is the case where I'm going to use fractions. I will be left with 94 divided by 5. How many times does 5 fit into 9? Once. 44 divided by 5, 8. Now, before I continue, I see that I need to add an extra 0. If I want to add an extra 0, it means I need to put a decimal point. And now 40 divided by 5 is going to be 8. And our final answer is 18.8. Alright student, I hope this makes sense. You've learned how to multiply decimals. You've learned how to divide decimals. Shouldn't be that complicated. When you multiply to put a decimal point, you just need to count how many digits you have after all decimal points. And when dividing, you're gonna move decimal point. If you move it here twice, then you also need to move it here twice. If you move 3 times here, then you're also gonna move 3 times here. Pick the digit that has the largest amount of digits after decimal point. That is how you're gonna move. So if here I have 1, then here I also gonna move 1. Here I have 1, so here I also move 1. If here I had 3 digits after decimal point, I would move 3, and here as well 3. If you have any questions, let me know, and I'll see you in the next video. Bye bye.